The explorations. This one's actually not. I looked at it today. It's not quite as bad as the other explorations. So what we're gonna do, and you can have your Chromebooks up, and make sure you're paying attention and not doing other stuff, because you don't want to get behind on this one. For whatever reason, these assignments, not for whatever reason, it's because it's not an easy assignment to find and do. These assignments, more than any other, I get a bunch of zeros on these because people at home and some people in class just don't do them. So log in. The only assignment that you should have available to you right now, unless you have something else that you didn't do from the previous day, is this view assets. So click on view assets, and it will take you to the page of the textbook where you can find the exploration.
32-minute video.
Christopher, the doorstop. There it is. Yes. Sticking the doorstop in so he can come in. So you're going to scroll to the bottom because we're in this section, geologic timescale, that I lectured on yesterday. You're going to scroll to the very bottom and click on this exploration. It's going to open up a new tab for you or a new window. Does it open up a new window on your Chromebook? Nice.
Yes.
All right. So it opens up a new window for you. It has an introduction, talks about the geologic timescale and the different periods. It has some instructions. And just real quick, so I can reference a couple things, I'm going to go ahead, go back up to the top of this page, and click on page 1. This is what we did the lecture on yesterday. So you can use this page, or I guess you can use the video. This page will probably be a little bit better. What they want us to do here, after the geologic timescale, is they want us to, I have 2 of them open. Let me close one of them, just so I don't have 2 of them open. They want us to take these events and put them on the geologic timescale when they kind of happened. And so I don't know that these are going to be easy to find. You can Google like Fusilids and find out when Fusilids happen. But I'm going to see if I can figure out when they happen. So Fusilids are not complex. They're like tiny little single-celled organisms that kind of have a football shape and a spiral inside. I actually did a paper. I helped a college professor submit a scientific paper on Fusilids. I don't know that my name was on it or anything. Maybe it was, but it was pretty interesting to do because they have a lot of different shapes and a lot of different types. So I think Fusilids is probably going to be somewhere here in the Precambrian. I'm going to guess the Proterozoic. Let's see if I'm right. Wait, hold on. How do I figure this out? Does it say no? Do I need to drag it up here? Okay, so it's not in the Proterozoic. You need to drag it to the name of the section that you're looking for. So try again. This event does not belong in the Proterozoic. Let's try the Archean. Nope, not in the Archean. What about the Precambrian? Nope. Come on. It's not the Hadean.
Do you want to know which one it is?
No, don't tell me. Don't tell me. Well, yeah, if you already got it, what is it?
It's down there in with the one on like the far left in the middle row. It looks like Mississippi on the left.
What, Mesozoic? Oh, far left. The Mississippian?
Yeah, that one right there.
It's in the Mississippian? I would not have guessed that. Wow. Okay. So Fusilids are in the Mississippian. Trilobites first appeared. Trilobites are probably going to be somewhere around there. I'm guessing maybe a little bit, maybe Triassic. If you figured it out, let me know.
How do they come up with these names?
I don't know. People get to name them.
They have no life.
Wait.
Yeah, they have no life. They spent their entire life trying to name something.
No. Hey, Trilobites is an awesome name. They're pretty cool.
Sounds like Cholo.
Devonian.
Sounds like a
Cholo.
Oh, it's a Cambrian early on.
No.
I would have never. Oh, wait over here. Well, I didn't see that was broken down. I would have never guessed that Fusilids came after Trilobites. That's crazy to me. Trilobites are a really, really good index fossil. I think Fusilids are pretty good too because they're really tiny, but they change a lot. So whale evolution begins. That's got to be not too early. That's got to be pretty late, I would guess. So whale evolution, I'm going to say somewhere after the Mesozoic. I'm going to go early Pliocene. Boom. I got something right. Mr. Bailey knows a little bit. So we got whale evolution in the Paleocene. Let's see. Early horses emerge. That's also going to be somewhere down here, maybe Eocene. Nope. Are y'all's coming in different order?
Yeah.
All right.
I'm just finding whatever one you're doing.
Yeah, that's fine. So horses were Oligocene, early horses. Look at that. Does that look like a horse today?
Yes.
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 You could ride that thing.
Dang.
It'd be dangerous. Largest mass extinction. The largest mass extinction. Let's see. I don't know. Was that the dinosaur mass extinction or was it the other one? I'm gonna go with the dinosaur one. Yeah.
It's not
Nope. It's not the Cretaceous.
Permian or whatever it is.
Go after the dinosaur one.
Yes, Permian. No, it's the P word.
The one right
There's
now.
lots of P words.
Over. Permian.
Oh, the Permian. All right, Permian. Largest mass extinction. The end of the Permian period marked the largest mass extinction in geologic record. Yeah, the 95% of marine species and 75% of land animals. So this was the extinction. Yeah, you can go. This is the extinction that opened up room for the dinosaurs to happen. We're doing so click on the view assets, go to the very bottom of the page, and click on exploration down there. First mammals appear. That's probably going to be before the whales, so maybe somewhere in the Mesozoic, Cretaceous. No. First mammals. Triassic? Yeah. So mammals were around during the dinosaur time. They were just small and not very evolved. And so this is our ancestors right here. The first mammals.
No way.
Reptiles appear. Reptiles got to be before the Mesozoic because that's going to be your dinosaur period. So maybe Devonian? Nope. Paleozoic? No. It's none of them in the Paleozoic? Surely it's in the Paleozoic somewhere. Pennsylvanian. So Pennsylvanian's going to be your first reptiles.
Oh, I didn't see that.
Look at that dude. He's got an awesome little spike ridge. Earth formation, that's going to be Hadean. That's early on. No, not in the... Oh, Hadean here. Earth formation is going to be in the Hadean.
Oh,
Yeah, that's your very, very first early, like,
I
hellscape.
was trying to put it in the box.
Oh, yeah, no, I did that a couple times. You got to drop it on the words. Modern mammals emerge. That's going to be after the dinosaurs are gone. So maybe Miocene?
It's
Eocene, so in between the whales and the horses. Jawed fish appear. I mentioned jawed fish yesterday in the lecture. I don't remember where it is. It's definitely going to be earlier. Yeah, Ordovician. All right. Because fish would have definitely come before like the emergence of reptiles. So you almost got to think about it like in an evolution kind of viewpoint. First bird-like animals appear. Yeah, that's definitely going to be after the reptiles show up. Nice. Nice. See, the lectures helped out a little bit, I guess. Did you find your thing you were talking about? The words underneath might tell you what it is. Bacteria flourish. Photosynthetic bacteria's got to be pretty early on. Something in Archean.
No, protozoa.
Proterozoic. Nice. Early bacteria. The spread of grasslands probably gonna be surely
Piece of thing. It's at the bottom.
what?
Oh, the
Pliocene?
yeah.
Nice. I would have thought grasses came a lot later than that, but never mind. Because before a lot of the plants were different trees and other plants, so I guess grasses came a lot later.
Holocene is the next one.
Modern humans rise. Yeah, that's going to be the Holocene for sure. Yeah, there we are. We've got sticks and fire. Most recent ice age. That's going to be the Pleistocene. I can help you out in a second. Vascular plants begin to evolve on dry land. Probably Miocene. Nope. Earlier than that. Let's go Devonian. Nope. Silurian. Yeah. So vascular plants on dry land is Silurian. That's a weird looking plant.
Where's Salute?
Silurians in the Paleozoic, in between Ordovician and Devonian. Kelp forests appear. So that's ocean plants. That's probably going to be early on.
It's the Mycene.
The Miocene, where's that?
Down at the bottom, right there.
Really? Kelp forests, huh? Okay. Oldest known rocks form, that's going to be the Archean. Just after the Hadean when everything starts to solidify. Flowering plants flourish. Maybe the Cretaceous? All right. And then last one, amphibians appear. The Devonian. There's your amphibians. So, was it amphibians came before reptiles? After reptiles. I don't know. I don't remember when the reptiles. Huh?
Why did whales lose their legs?
Because they didn't use them. They didn't need them. And I imagine it happened slowly. Maybe a whale was born with like tinier legs. They didn't lose their legs. They turned into fins. They still have the legs. They just don't. They don't look like our legs anymore. And actually, when you look at that, that's one of the things that helped us kind of understand that. Like when you look at bird, maybe not bird wings, but bird wings are kind of similar, or bat wings. They look like hands. Like the bones are just like our hands. They're just spread out further, and they have more webbing in between their fingers that make up that fin, or the wings. And the same thing with whales. If you look at like a whale fin, it's got bones just like a hand. It's just all fused together, and they don't have fingers. So it's the same kind of evolutionary pattern.
So
it just
we're
didn't end
bat
up as the same thing. Huh?
We're bat whales. All
Yeah.
things are bat whales.
Yes. That's exactly what I was getting at.
Yep.
All right, so look, when you get done with this, you have 5 questions. So this one's not nearly as long as the other ones. Huh?
There's another deal.
Oh, there's another deal?
So go.
Oh, sorry. I thought there was only 5.
Wait, did you tell the other classes that there was only 5?
Y'all are the only class, so no. No. So there's 11 questions. So take your time on this. If you have questions about something, let me know. Make sure you're trying to put a little bit of detail into your answers. You know, it doesn't have to be like a whole paragraph or something, but make sure you're explaining yourself fully, so I can give you full credit on all these. At the end of the day today. So
Today?
yeah. If you need more time on it, you can let me know. But yeah, if you don't think you're gonna be able to finish it in class, what time does class end here?
11:33.
33. So you still got about 20 something minutes, almost 30 minutes. So you should be able to get it done. If you don't think you're gonna finish, maybe take some screenshots of your answers. So if you close it out, you can come back and I don't know if it's gonna save your answers or not. Well, actually, there's a save button in there. Yeah. So make sure you hit save before you leave if you're not done. And if you are done, make sure you hit submit. Because you want your answers to be saved. So,
Where do we find the answers?
either on this chart where you put stuff, which actually, like, I feel like you should be able to. Oh, you can go to Tracker, and Tracker will tell you all the stuff that you just put in. So if they ask about something specific, you can find it and figure out when it happened. But like, let's look at some of them. I can help y'all out with some of them. Let's see.
I'll put with the first 10.
Huh?
With the first 10, and then I'll do the last one.
We'll see. Maybe.
Yeah,
Does somebody else have a
wait.
question?
I didn't get any of this because you went kind of fast and I can't read any of that. It's too small.
Hold on. I'll come help you out in a second. I'll come help you out. So, like, question number 1.
Yes.
What is the primary difference between the Precambrian eons and the Phanerozoic eon of the geologic timescale as seen in this exploration? The Precambrian stuff just didn't have very much life. The Phanerozoic is where all the life starts to flourish and everything starts to happen. So if we come down to the Precambrian stuff, yeah, here are your Precambrian things before you get to Phanerozoic. and you have like bacteria, rocks, and the formation of the earth. And so there's not a lot going on as far as life is concerned in the Precambrian. The Phanerozoic has literally everything else. Okay, how are the Permian Triassic boundaries and the Cretaceous Tertiary boundaries similar? Those boundaries are going to be mass extinction events. And we talked about that yesterday. A lot of these different divisions are when something happened and a whole bunch of animals died off because of that. Either sea levels rise or they dropped, or we had an ice age, or an asteroid hit and killed the dinosaurs. But those two things are definitely going to be your mass extinction events, because they even have one of them that was on here. I think it was the Permian one. Permian Triassic boundary. Let me go back up here. Let's see. There you go. In the Permian, you had the largest mass extinction. So that's what ended the Permian and brought about the Triassic. So that's going to be what is common between those two boundaries. Which epochs of geologic time do you think anthropologists are most interested in? Explain your answer. So they're talking about epochs. Let's see. What? Which epochs of geologic times? Oh, what do anthropologists study? That's the key here. Does anybody know what anthropologists study?
Anthros.
What are anthros?
I don't know.
You all have Chromebooks right in front of you.
Rocks.
What do anthropologists study?
Fossil. People's pulse.
Look it up. Just Google it. Anthropologists. He's doing it. What do anthropologists study? Yes, they study what?
Clothing.
They study human behavior. So in what epoch are anthropologists going to be most interested in? Yeah, where are the humans at? Huh?
The Phanerozoic.
No, you're looking for the epoch. So on here, which one of these have humans on them?
Holocene.
Yeah, the Holocene is where the humans are at. Where the rise of the modern humans.
So like, are we what started that epoch?
Huh?
Are we what started that epoch?
Yeah, the rise of the humans would have been what started that one.
If we weren't here, would the Pliocene or Pliocene still be in?
Probably, but if we weren't here, we wouldn't have names for any of these. So, but yeah, if we weren't here, maybe there'd be something else that replaced us. Maybe the mice would be super smart, or the dolphins, or something. Yeah, I think the dolphins for sure. Yeah, or maybe octopus, octopi are very scary.
Dolphins or monkeys?
Or the ostriches. But make sure you say why. Don't just put the Holocene. Tell me why anthropologists are interested in the Holocene. Number 4. Describe a possible cause for the extinction of the dinosaurs at the end of the Cretaceous period. I think we all know the possible cause of the extinction of the dinosaurs. So describe that. Don't just give me a one-word answer. Give me a good description. A paleontologist studying whale evolution is planning a field trip to India. He is using a geologic time map to figure out where exactly to go. What age rock formation should he be looking for? Explain your answer. So go up here and find out where the whales came about. That's one of your things over here. And they're asking specifically just what age rock formation. So they want the dates on that. So find the whale evolution one and come over here to the date side and let him know, that whale anthropologist, what year time frame he should be looking for to look for whale bones. And I'll come help you finish this in just a second. Geologic time scale number 2. Question 6. What do you think the Hadean and Archean eons are not further divided into periods and epochs? So they're talking about the stuff at the very bottom here. The Hadean and the Archean. Why aren't they divided into different epochs? There was 2 reasons that I talked about yesterday. Does anybody remember? So what was going on here?
The Earth was getting hit by meteors.
Yeah. So what would keep us from giving a bunch of different divisions? Notice when we do a lot of different divisions up top, all this stuff is happening to life forms, and we're looking at the fossils and seeing what died and what came about. So at the very early part of the Earth, do we have any fossils? No. And how old are these rocks? They're like billions of years old. So is it probably going to be easy to find a lot of rocks from this area or this time frame? No. So those are going to be your two reasons. There's not any fossils because there wasn't very many life forms. They didn't have hard parts. And the rocks are not abundant. They've all been broken down and weathered and recycled. Yeah.
So it's not possible to find a rock from the Haiti?
It's possible. You just don't find a lot of them. And when you do, they don't have a lot of context to tell you a lot of details about what was going on.
How can they time it back to the Haiti?
We find radioactive materials, and basically, I actually had a friend when I got my first degree of geology at UTA. One of my classmates, I don't know if she ever ended up going, but she got an offer to go to like Stanford to study zircons, and so basically, they will find little crystals of some of these rocks embedded in other rocks that are not quite as old. But they go into these crystals and they have radioactive elements inside them. And looking at the radioactive elements, you can date that little part of the rock because it's kind of encapsulated in this time capsule of the surrounding rock. And so it's kind of hard. It requires a lot of extrapolation and trying to figure things out. But we find little tiny bits of stuff that was that old. And so we use a lot of radioactive elements to do that. And I think we will talk about that in this section, not this chapter, but no, not in this section, but in this chapter of the book. We'll talk about radioactive dating and how that kind of works and how we understand that. And so that's pretty cool. So let's see, number 7. If Earth formed 4.56 billion years ago, why are the oldest rocks found on Earth younger than that? Same answer. Because it's so old, they've either been weathered away, or they're buried deep in the ground, or they've been remelted back into lava and magma. And so we can find stuff that's close to this age, but they're really small, and you're not going to find a whole bunch like that. Let me actually just Google it real quick to see what is the oldest rock we found.
Never go back to the Bob.
Was the oldest? What is the oldest rock we have found? Oldest dated rocks. Yeah, this says 4 billion years old, formed during the Hadean Eon, but not all the way back to the very beginning, 4.56 billion years old.
If you found one, like let's say in your backyard somehow, could you get rich off that?
I don't think you get rich. You could maybe like sell it to a like a museum or something, but I mean, it would definitely like maybe pay for your kids' college and send you on a vacation, but you're not gonna be like mansion and like nice cars rich. I don't know, because I mean you got to think about it. Some of the museums are really nice and they're gonna pay you a decent chunk to sell it, but you know it's a museum. They don't have like hundreds of millions of dollars to just throw around at rocks. And while they'd like to study rocks, ain't nobody going to a museum to look at a rock.
But it's from 4.5 million years.
Yeah, it'd totally be unique. But to be honest, they have people that are really good. They're going to come in and they're going to try to guilt you into giving it to them for science. They're like, you know, this is we'll give you some money, but we can't afford no like millions and millions of dollars. You sell it to some billionaire. He's just going to keep it in his house, and you're going to make the human race dumber by not letting this be studied for science. They're really good at it. They're really good at it. They'll be like, we'll name like a wing of the museum after you or something. Yeah, but a lot of people do care.
I'm not one of those people.
And to be honest, yeah. In order to find something that you get to keep like that, it almost has to be your land, or it's got to be on public land.
But then they're
what was
like,
You go find it on someone else's land, and that's the first thing they're going to ask you. If you find like a 4.6 billion year old rock, they're going to be like, "Where did you get this from?" And if you can't tell them, they're probably not even going to talk to you anymore. And if you're not like, "I found it on my property,"
I didn't find it on my property.
there's going to be lawsuits
Then
and
I don't
stuff.
care how much I sell it for as long as I get money. But if I found it on my property, you see where I'm going? If it's
It
not
just
on
Yeah,
lie and say
I
it's
see
not
where you're going.
yeah, no, like I'm just gonna try to get rid of it quick. You know?
Yeah, but I don't know that anybody's going to pay you a lot of money without knowing where it came from, and knowing that, because if they pay you like $1 million for it, and then they start to do science on it, and the landowner's like, "Hey, that's my rock. That came from my land." They're going to come back to you, and they're going to take that $1 million back.
What if it's already like spent?
That would-
Oh, they can confiscate whatever you spend it
That
on.
would suck.
Like,
You got $1 million and they gotta take it away.
yeah, for real. Telling you. There's been people that have cheated on game shows and stuff and gotten caught later.
And they take the money back?
Yeah, you don't get to keep the money if you get caught cheating.
That's
Nah.
tough. And you
Nah.
get embarrassed too.
And if you spent some of it, yeah, they're gonna sue you, and they'll like take your car that you bought and take the house that you bought and sell it and get as much back as they can. Yeah. So let's see. How do you think the geologic timescale was created in the first place? How did geologists decide to separate one period or epoch from another? Well, it was created just out of necessity. In the same way that the calendar was created, we just needed some way to mark time and some way to tell other people about how old things were. How did geologists decide to separate one period from another? You look for big events that happened worldwide. An extinction just in North America isn't going to make sense to a scientist in China or in Europe or in Africa or South America. So you look for these worldwide extinction events or climate change events or something big that happened that goes all around the world, and that way you can mark your time periods for that. Number 9, how do you think we know exactly in years when a time period began and ended? We don't. These are rough ages, and they change from time to time. But we use the radiometric dating, and we try to get close enough. But anybody that tells you like it was literally exactly 439 million years ago is wrong. And you'll notice that if you come back next year when I'm teaching this class, for those of y'all that aren't seniors, everybody's senior in here. No. Okay, I didn't know. Don't get mad at me. I don't have specific classes that
I'm a freshman.
juniors or seniors or whatever. I know that freshmen don't. I don't get any freshmen ever. Which, no offense if you're a freshman and you watch this video, but I'm glad that I don't get any freshmen ever. It says 439 million years ago. If you come back next year, it's not like 439 million in 1 year. It's just roughly. That's what we get at. And every once in a while, we'll find a rock and we'll date it, and they'll kind of adjust the dates a little bit. But when you get back to millions or hundreds of millions of years ago, being off by a couple thousand or even a couple 100,000 years isn't really a huge
What
deal.
did you say for number
9? I didn't do number. Oh, yeah, we did.
That's the one we're on right now.
Yeah, that's the one we're on.
9? Oh.
We use radiometric dating when we get close, but we don't know exactly in years. The radiometric dating gets us close in years, but it's not an exact thing. So we use the radioactive elements to help us figure out when that happened. Every so often, geologists revise see, like I said, we change it every once in a while. They revise the geologic time scale, changing beginning and ending dates of certain areas, periods, and epochs slightly. Why do you think they do this? Because we're always discovering new things. There's always new stuff to learn. We haven't found every rock in the earth. We haven't looked at every layer. We haven't found every dinosaur bone or different species. And so we find new stuff. And as a scientist, you have to be willing to be like, I was wrong. I got better evidence now, and now I understand it a little bit better. And be that way as a person, too. You say something, and then someone's like, I think you might be wrong. There's nothing wrong with being like, yeah, I got that one wrong. I thought this thing, and I guess I didn't know what I was talking about. I have to do that all the time. Guys, especially when you get a wife, they're gonna prove you wrong on stuff, and you're gonna look stupid if you're like, no, I know what I'm talking about, and then they just pull out their cell phone. Like y'all were just, you gotta look up something and make sure that you're right before you tell people. Yesterday, I looked like an idiot in front of my friend because does anybody know who Eddie Van Halen is?
Yes.
Eddie Van Halen died, and I was telling him, this is gonna sound so dumb, but I used to watch this movie called the Jetsons movie when I was a kid. And the Jetsons, you all know the Jetsons. The dad, George Jetson, got a new job, and they moved to like a different planet where they were mining stuff. And it's kind of like this. There's like little creatures that live on the planet, and he doesn't want to like kill them to mine for his company. And anyways, I could have swore, like I would have bet money on it a couple days ago that there was an Eddie Van Halen song in that movie. And I don't know if it was in the credits or what, but I told my friend about it. I was like, one of the best Eddie Van Halen songs, or not the best, but one of the ones I remember the most was in this movie. And then as soon as I texted, I started to look for it so I could send him like a YouTube clip or a picture or something. And I was wrong. Like, he's not in that movie at all. There's no Eddie Van Halen songs in any movies like that. I don't know what I was thinking. Obviously, I was a kid at the time. But I would have been like 100% sure. I will bet you like $100 3 days ago. And as soon as I found the text, I was like, oh, I guess I'm stupid. And I had to text him back and be like, I'm an idiot. I don't know what I'm talking about. So, yeah, sometimes you just got to admit that you're wrong because your brain will lie to you. It'll tell you you know things and then you don't. So I went through number 1 through 10. That means I don't have to do 11, right?
What was 10?
I already said number 10. Every so often, a geologist revises the time scale, changing the beginning and end dates of certain areas, periods. Why do you think they do this? Because we get new information. We got to admit that we're wrong. Sometimes we find out new stuff. Yeah, you can go. We find out new stuff, and we got to change our answers because we're scientists, and you got to trust the science. You got to go with the data. So, and then I'll let y'all finish number 11. I'll leave a little bit of a challenge for
I
you.
need help
So,
on number 11.
what? 3 layers of sedimentary rock. Oh,
I ain't even ready yet.
actually, yeah. Let me see. Hold on. Early horse, middle layer, top gold, shallow. What can help these layers? See, they haven't even gone over this yet.
Right?
Huh?
The trilobite are those little bugs, right?
Yeah, the trilobites, they're like little, like, have you ever seen a horseshoe crab? They're related to horseshoe crabs. So this one, it tells you got 3 layers. In the bottom layer, she finds fossils of an early horse. In the middle layer, there's coal. And in the top layer, there's trilobites. So first off, let's find out where the horses and the trilobites are. So if we come up, the horses are modern mammals. Early horses are in the Oligocene. Where are the trilobites?
They're like one of the first ones at the top.
Yeah, they're way down early. Trilobites were the Cambrian. So trilobites came early on, and then the horses came later, right? So let me actually draw this over here. And I'm not going to answer this for you, but I'm going to lead you right to it. So hopefully everybody can figure it out. So when you're looking at rock layers, where should the oldest stuff be?
On the bottom.
On the bottom. Yeah, it's not going to be on the top. The stuff on the top just came like yesterday, the day before, or last year. The oldest stuff should be on the bottom. So if you have these 3 layers, this is going to be terrible, but this is a horse. It's got a ponytail.
Oh, no.
Oh, that's terrible.
That was big.
Yeah. Okay. I'm actually kind of proud of that. That is, you can tell that that's a horse just from a distance. Or like a hippo with a big tail, but whatever. So that's a horse. And then you got your trilobite here, which has like a head like this and then these different layers. It's like a little crab bug kind of thing. It's got a bunch of little legs that come off the side. Yeah. So the trilobite is the oldest thing. It should be on the bottom. The horse fossils are the youngest thing. It should be on the top. But in the question, what does it say?
It's flipped.
Yeah, it's flipped. So what happened to put the trilobites in the, wait, no, hold on. Yeah, it is flipped. In the lowest layer, she finds the early horse, and the middle layer is coal, and then the top layer is trilobite. So how do we get from where it's like this to what she's finding?
It flipped.
Yeah, literally, it got flipped. Something happened, probably plate tectonics or some sort of mountain building, where all of this gets turned up and then gets folded completely over, and your older layers end up on top and your younger layers end up on bottom. Because there's no way for those to actually be in that order unless the layers were changed. And so something had to happen where, y'all see my nice picture, where your horse ends up on bottom and your trilobite ends up on top. So it's going to be some sort of force that actually changed the rocks and made them switch places. So
Do I have to fill out this graph or whatever? Or is it like, do I have to?
no, the graph's not part of the grade. It's just the questions. So if y'all have any questions at home, please let me know. I hope you watch this video and it helps you out with the assignment. And I will see y'all tomorrow. We'll do a constructed response on this section. Thank you. Have a nice day.